Good evening, children.
Good evening, ma'am.
Good evening. Good evening. Just a second, children. Yeah. Yeah. Good evening, children. Hello. Are you all out there?
Good evening.
Good evening.
Good evening.
Good evening, children. Fine. So we'll take up some important questions from constructions today. I'm not doing the. I'll come from behind. We'll not do the direct ones where we have to construct tangents, a pair of tangents from an external point of the circle, or dividing a line segment in a specific ratio. So all that I'm sure by now, after writing 2-3 trial exams, you're aware of that very well. Okay, so let's see this one. Draw a circle with the help of a bangle. Draw a circle with the help of a bangle. So what happens when you draw a circle with the help of a bangle? You do not know the center of the circle. When we draw a circle with the help of a bangle, we do not know the center of the circle. When we draw a circle using a pair of compass, then you know the center. Using a compass, when you draw a circle, you know the center of the circle. You can mark the center O of the circle, but when you draw a circle with the help of a bangle, you can draw a circle, but you cannot identify or you cannot mark its center. So the first task is to identify the center of the circle. I'm not reading the question ahead. I'm not reading the question ahead. So, or the instruction ahead. So first we'll draw a circle with the help of a bangle. So we have a bangle with us. We draw a circle with the help of a bangle. All right. Okay, please excuse me. It's not a perfect circle. Now we need to identify the center of the circle, for which we have to take 3 points, say A, B, C, any 3 points on the circumference of the circle. What are we doing now? We're trying to identify the center of the circle. Okay, so we take 3 points A, B, C on the circumference of the circle. We join A to B and B to C. We then construct the perpendicular bisector of the line segment or the chord AB. AB and BC are chords to the circle. They're intersecting chords. AB and BC are 2 chords that intersect at B. AB is a chord, BC is a chord. Now what are we going to do next? We are going to construct the perpendicular bisectors of the 2 chords. So that you know how to construct a perpendicular bisector, you know, when you have a line segment, you're going to put your compass tip at this point and this point, and using a convenient radius, you're going to draw an arc here from this point with this as center and a convenient radius. You're going to draw an arc above and below the line. And then from this point, using the same radius, you're going to cut the earlier arcs and then join this and then join this. So this is the required perpendicular bisector of this line segment. You know this. Sometimes we call it the, and some teachers call it the 4-arc method, whatever, 4-arc method to construct the perpendicular bisector of a line segment, 4-arc method. So from using these 2 endpoints as centers and a convenient radius, we draw arcs and we connect these 2 points. So this we know. So that is what we're going to do here. Using so simple, we're going to construct the perpendicular bisector of AB. So using A and B as centers, we're going to draw 4 arcs. Okay, so this is the perpendicular bisector. You should use A and B as centers. If you take a very small radius, the arcs will not meet. If you take a very small radius, the arcs will not meet. So you must take sufficient radius so that the arcs intersect. So in your lower classes, you would have heard the teacher say taking a radius more than half of AB, more than half of the line segment AB. Okay, so like that we construct the perpendicular bisector of the chord AB. Next is to construct the perpendicular bisector of the chord BC. So you must use B and C as endpoints or the centers of the circle. Sorry, center for the arcs. Use B and C. Place the tip of your compass at B and C. From B, draw an arc like this. Draw arcs above and below the chord BC. And from C and the same radius, cut the earlier arcs and join. So like that, you will get the perpendicular bisector of BC. Let me draw that and then show the arcs. OK, I hope you understand why. Like this. Now, this point where the perpendicular bisectors intersect is the center of the circle. This is the center of the circle. So we first draw a circle with the help of a bangle. Next, we mark 3 points A, B, C on the circumference of the circle. We join AB and BC. Thus, we get 2 intersecting chords, AB and BC. Next, we construct the perpendicular bisector of chord AB and also the perpendicular bisector of the chord BC. The point of intersection of the perpendicular bisectors is the center of the circle. The point of intersection of the perpendicular bisectors is the center of the circle. And now you know how to draw tangents to the circle from an external point. Now let's read the information or the instruction ahead. Let's read the instruction ahead. So we drew, what did we do? We drew a circle with the help of a bangle. Am I audible and clear, children?
Yes, ma'am.
Yes, ma'am.
Okay. So what have we done so far? We drew a circle with the help of a bangle. Okay, then we did not know the center of the circle. So we using a particular procedure, we identified the center of the circle. So now we know the center of the circle. This is the point O. Okay, now read the instruction ahead. Take a point outside the circle. So any point, you're free to take anywhere outside the circle, anywhere, this side, above, below, any side. But mostly the right side is comfortable. That's all. Mostly the right side is comfortable. So you take a point. You can take a point anywhere around the circle. But we normally the right side, or if you feel the left side is comfortable, take it there, wherever. So I've taken here on the right side of the circle. Okay. So take this point, any point, take a point outside the circle. So I've taken this point outside the circle. Let's call the point P. Now from this point, you have to, what's the next thing? Construct a pair of tangents from this point to the circle. From this point P, you must draw 2 tangents. So like this, from this point P, you have to draw the 2 tangents to the circle like this. You must draw these 2. Meaning you must construct these 2 circles. Oh, I'm sorry. You must construct these 2 tangents from this point P, which lies outside the circle. This is the circle with center O. From this external point P, we need to draw the tangents, the 2 tangents to the circle. Okay. So for which we'll also understand why this construction works. Why the construction works, we'll understand. I'll just take the point closer, children, so that I'm able to draw the circle decently good. Let me see. I don't want to promise that before I draw, actually. Let me take it closer to the circle. So let me take the point P here, okay? Anywhere you can take the point P. Outside the circle. Now join OP. This is the regular procedure. You're well aware of this. How to construct a pair of tangents from a given point outside the circle. You know that. So join the center of the circle to that external point. Join the center of the circle to that external point. Construct the perpendicular bisector of OP. P is the external point, O is the center of the circle. So we join OP. That's the first thing. Then we construct the perpendicular bisector of OP. So like this. It can intersect the circle, not that it should touch the circle like this, children. Don't think the perpendicular bisector should touch the circle. It can be outside the circle also. Here it just happens like that. Okay, so we join OP, and we construct the perpendicular bisector of OP. So what happens? This becomes the midpoint. This becomes the midpoint. Let's mark this M. Children, it's not that the perpendicular bisector should touch the circle or cross the circle like this, please. It can be outside the circle also. The perpendicular bisector can be completely outside the circle. Depending on the distance, if you take P very far away, the perpendicular bisector will be clearly outside the circle here like this. Okay, so now this, because perpendicular bisector, no, so this let's mark the midpoint. This will be the midpoint M of OP. Now you have to draw a circle. And wrong. Are we all there?
Yes.
Yes, ma'am.
Yes, ma'am.
1 second, children. Oh my God, I have to do it again. Yeah, sorry, children. Yeah. So what was I telling you? So this point M is the, am I audible, children?
Yes,
Yes,
ma'am.
ma'am.
Okay, so M is the midpoint of OP. Now we need to draw a circle with OP as diameter. What is O? Center of the circle. What is P? The point outside the circle. We need to draw a circle with OP as diameter. We need to draw a circle with OP as diameter. So what do we do? This is the midpoint. So with M, use your compass. With M as the center and radius equal to OM or MP, because see here, you want OP to be the diameter. You want OP to be the diameter. If OP is the diameter, then OM is the radius or MP is the radius. So with MS, so that means M will be the center of the circle which you're going to draw. See, you've planned everything. You're just executing that. You want a circle with OP as diameter. And you know that M is the midpoint of OP. That means M is the center. M will be, OP is the diameter. You want OP to be the diameter of the circle which you want to construct. That means M will be the center of the circle because M is the midpoint of OP. Because we constructed the perpendicular bisector of OP. So now with M as center, and radius equal to MO or MP, draw a circle. So that's because you're taking M as center and MP as radius, that circle will pass through. The circle will pass through O and P. So it will be a circle like this. Because see, you have taken M as a center and radius as MP or MO. So clearly OP will be the diameter to the circle, M being the midpoint. Now this new circle intersects the original circle at this point and this point. This new circle intersects the original circle at these 2 points. Here the two circles intersect, these two circles. So here these 2 points, this point and this point. These are the points of intersection of the two circles. Now join. So you can mark this point like you can call it T and T dash. T and T dash, join PT, join PT dash, join PT dash. These are the required tangents to the circle. I'll tell you why the construction works. This one is too clumsy to explain. I'll just show you in a different figure why how this construction works. So this is what it is. So after identifying the center of the circle, we take a point P outside the circle, we join OP, and we want OP to be the diameter of a new circle which we are going to draw. For that, we construct the perpendicular bisector of OP, and we locate the midpoint M of OP. Now with M as center and radius MO or MP, we draw a circle, and the circle will pass through O and P. OP will be the diameter. Now we have two circles. They are two intersecting circles. Mark off the points of intersection as T and T dash. The two circles intersect. So mark the points of intersection as T and T dash. Join PT and PT dash. They are the required tangents. We know that we can draw only two tangents from an external point of the circle. So PT and PT dash are the required tangents to the circle. To show you how this construction works. Yeah. So how does this construction work? Or how can we justify this construction? So children, circle, then, you know, forget that construction to identify the center. OK, I'm not showing that. So there's a center. This is that external point. This is center O, this is the external point P. And then we constructed the perpendicular bisector. OK, we constructed the perpendicular bisector. And then we do the circle. We do the circle. OK. Now we said that these are the tangents. This one and this one are the tangents, PT and PT dash. Now look at the new circle, children. Look at the new circle. Not the original one. Look at the new circle. Now, for the new circle, this is the diameter. This is the diameter. And see here, if I join this, if I join OT, this one, if I join this, OT, if I join this, this is OT. This is the radius of the original circle. This is the radius of the original circle. Forget that now. I'm just joining OT. OK, see, now for the new circle, OP is the diameter. OK, for the new circle, OT is only a chord. For the new circle, OT is only a chord. See, it's like this. Angle in a semicircle is a right angle. If this is the diameter and we have, you know, two chords like this, we know that this is 90 degrees. See, like this is O, this is P, and this is T. This is OT, this is OT, and this is PT. This is the diameter. Angle in a semicircle is a right angle. We know that angle in a semicircle is a right angle. Angle in a semicircle, if OP is a diameter, then this one is 90 degrees. So see here, OP is the diameter for the new circle. And see, you can see this one. That is from T is a point on the circumference of the new circle. We join OT and like PT. So this is 90 degrees. The angle in a semicircle is a right angle. For the new circle, OP is the diameter. Now see here, this one, OT, PT. The angle formed here is 90 degrees. So we know that angle OTP is 90 degrees. Because the angle in a semicircle is a right angle. From the new circle, For the new circle, this is not the radius. This OT is not the radius of the new circle. Because this is the center of the new circle. This is the center. And the radius will come from the center, right? Center to circumference. So OT is just a chord to the new circle. OT is the radius to the old one, the original circle. So see, you can see this the diameter. You can see the diameter, and you can see OT here, and you can see PT here. So please relate to what you learned last year. Diameter 90 degrees. Angle in a semicircle is a right angle, provided this is the diameter. And yes, OP is the diameter to the new circle. So since angle in a semicircle is a right angle, this is 90 degrees. Angle OTP is 90 degrees. Now go to the old circle. For the old circle, OT is the radius. And the radius makes 90 degrees with the line TP. That means TP should be the tangent to the circle. For the original circle with center O, OT is a radius because from the center O to a point on the circumference T. So OT is a radius of the original circle. And this radius OT makes 90 degrees with some line segment TP. This one. So that means radius is perpendicular to something. That means that something is a tangent to the circle. So PT is a tangent. Same thing here. If you join, you can see below like this. This is also angle in a semicircle, 90 degrees, right angle. So you should join OT dash. If you join OT dash, this angle, that is angle OTP is 90 degrees. Angle in a semicircle is a right angle. 9th standard, angle in a semicircle is a right angle. And also angle OT dash P is 90 degrees. OT dash P. See here, I'm showing you again, new circle. This is the diameter. So below you can see, so the diameter like this one, the 90 degrees. So like that's your diameter. You can see this below. Like this, 90. So angle OT dash P is 90 degrees. Now, after getting this is 90, now go to the circle with center O and say that OT dash is the radius. Now go back to the circle with center O and say OT dash is the radius, and the radius is making 90 degrees with T dash P or PT dash. That means PT dash is a tangent to the circle. So for the new circle, you can identify angles in a semicircle. So that will be equal to 90 degrees. And then in the old circle, you must say, that is the original circle, you must say that the radius is making 90 degrees with 2 lines. Then those 2 lines must be tangents to the circle. Maybe you can use a recording and try it, children. It's not possible to construct now. This one. Class, use the emoji. Raise your hand. Thirunesh, Hariharan, Shakti, Shabari Krish, Priya, Srinivasan, Lakshita, Nivedita, Sudarshan, Priyadarshini, Aksharam, Shivani, and Muthuvel. Are you there? Yes. No. Yeah, you're there. All right. Okay. Let's see this one, children. Let ABC be a right triangle in which AB is equal to, no, I will not read the instruction completely. We'll just read part by part and we'll try to construct if possible. Okay. Let ABC be a right triangle in which AB is equal to 6 centimeters. BC is equal to 8 centimeters and angle B is 90 degrees. Okay. Let's do that. So ABC is a right triangle. So like this 6 and this is bigger 8. So you know how to construct. You know how to construct a right triangle, meaning you know how to construct a triangle. So I'm not showing you the construction. We need to first take BC is equal to 8 centimeters. You should draw a rough diagram. This is your rough diagram. This is 8 and this is 6. So first take a line segment BC equal to 8 centimeters. At B construct 90 degrees and with B as center and radius 6 centimeters. Cut an arc and join. That's the point A and join AC. Construction of triangle. Base BC 8 centimeters. Here you should make 90 degrees. How will you make 90 degrees? So this arc 60 degrees, 120 degrees, and then bisecting these two 90 degrees. You should not use a protractor. You must construct. This is 60. This is 120. And when you bisect the angle between 60 and 120, it's 90. So this is 90. This is 90 degrees. And with B as center and 6 centimeters radius, cut an arc. That's the point A. Join AC. Okay, so like that we got this triangle ABC, in which AB is 6 centimeters, BC is 8 centimeters, and angle B is 90 degrees. BC 8, construction of 90 degrees here at B, with B as center, radius 6 centimeters, arc here, that's the point A, and we join AC. Okay, so we've constructed the triangle. BD is the perpendicular from B on AC. BD, okay, so there's a new point D. BD is the perpendicular, okay, from B on AC. So here again, we're going to use a, a concept or a theorem which we sorry, children. So yeah, so we've learned a theorem, last year, circle, chord, midpoint, center to midpoint. If you join, then this is perpendicular. The line drawn from the center of the circle to bisect the chord is perpendicular to the chord. Circle, center, you know that this is the midpoint of the chord. You know that. You're given that this is the midpoint of the chord. And you join the center to the midpoint. Then that line is perpendicular to the chord. The line drawn from the center to bisect the chord is perpendicular to the chord. If you draw a line from the center of the circle to bisect the chord, that means to the midpoint of the chord, then that line is perpendicular to the chord. We're going to use this idea to get 90. BD is perpendicular. No, so see this 90 degrees, this 90. We're going to use this theorem to get BD perpendicular on AC from B. Okay, you will understand once we finish. So now what you have to do is you just assume B to be the center of a circle. Okay, assume B to be the center of the circle. Now using B as center and any convenient radius, You must draw an arc so that it intersects the hypotenuse at 2 points like this. You can take any radius. See, supposing the radius is very small, maybe the arc will come only here like this. Take sufficient radius. Take sufficient, it need not be in the middle or something like that, anywhere with, with B as center. With B as center and any convenient radius. Draw an arc to intersect the hypotenuse AC at two different points. So now what happens? This is an arc. This is an arc. If you complete it, it will become a circle. But it's now an arc. Arc is enough. We don't want a circle. We don't want the construction to be clumsy. Or we don't want the circle. So we're not completing the circle. If we complete the circle, then you can make out that this is a chord. Even now, it's an arc and it contains the chord. It's an arc now and it contains a chord. Can you see it? Can you see this arc? And it contains this chord. It contains this chord. With B as center and any convenient radius, draw an arc to intersect the hypotenuse AC at two distinct points. After this, you need to find out the midpoint of the chord because you know this is the center of the circle. Now you want to see arc and chord, arc and there's a chord. The arc contains a chord. See here, this is the arc. This is the arc and it contains a chord. Now the next thing is to locate the midpoint of the chord. So we know how will you locate the midpoint with this one and this one as center. And it can be different from the earlier radius. You should draw arcs like this. With this as center, I repeat, see here. Now, what was the first thing? With B as center and any convenient radius, we draw an arc so that it intersects the hypotenuse AC at two distinct points. That's over. Now you can change the radius. You can change the radius. Now what you should do, now you've got 2 points, right? This point and this point on the hypotenuse. Using these 2 points and a convenient radius, draw an arc and cut it. Draw an arc from here and from this point cut the arc using this point and this point. We know that how to draw an arc and cut the arc. You just need the points from this point and any convenient radius, draw an arc and cut the earlier arc. Now draw a line connecting B through this point. You will see that it will meet the chord at its midpoint. It will meet the chord at its midpoint. What did we do? Using this point and this point as centers and a convenient radius. So from this point, we first draw an arc and from here we cut the earlier arc. We cut the earlier arc. Now this is B and we've got a point here. So we connect through from B through this one. We extend it till it meets the chord and it will meet the chord at its midpoint because it's like you're constructing the perpendicular bisector. See, if you cut the arc, these 2 arcs are not needed. If you cut those 2 arcs also, it will pass all this. You can connect it by the same line. This part is not needed. We are not showing the other side. So now this is the midpoint. This is the midpoint of the chord, not the hypotenuse AC. Now don't get confused. This is the, there are many other concepts related to this, children. I'm telling you what you need for the construction. So now you forget the hypotenuse AC. We are talking about the chord. This one is the midpoint of the chord. This one is the midpoint of the chord. So what have we done? From the center B, we have drawn a line to the midpoint of the chord. Then that will be perpendicular to the chord. So this is the point D. This is the required point D. This is the required point D. Because BD is a line from the center. Now you will wonder how center. Yeah, because for this arc, this is the center. For the arc, B is the center. If you complete, you'll get a circle. For the an arc, if you draw an arc, you're drawing an arc using a compass. That means there is a center, right? That's the center for the arc. Okay, so with B as center and a convenient radius, we drew this arc. Now what happened with B as center and through this point, with B as center and through this point, we extend it till it intersects the chord. And you know that because this is like a perpendicular bisector. And so we know that it will intersect the chord at its midpoint. So BD is a line segment from the center to the midpoint of the chord. And by the theorem, it will be perpendicular to the chord. By the theorem, it will be perpendicular to the chord. So BD is perpendicular to AC. If BD is perpendicular to the chord, it will also be perpendicular to AC. This is how you draw BD perpendicular to AC. Just show you again quickly. B, arc, this point, arc, this point, arc, and like this. See this point, and through this point you should go like this. This will be the midpoint of the chord, so it will be perpendicular to the chord. So this one makes 90 degrees with hypotenuse AC. That's what we want. That's what the instruction is. Draw BD. BD is the perpendicular. Yeah, BD is the perpendicular from B on AC. BD is the perpendicular from B on AC. Yes, it is. Now you will have to next. We are executing one by one. So we first do the we first do the, I think there are 4 parts in this, this one has 4 different instructions. Okay, so the first instruction is to draw the right triangle with this information. Next is to draw BD perpendicular from B on AC. Next is to draw the circle passing through BCD, and finally constructing tangents from A to the circle. So we have to execute 4 instructions. So construction of, we've already done 2. We constructed the circle, then we drew BD perpendicular to AC from B. Now the third one, we are going to execute the third one, the circle. We are going to draw a circle passing through B, C, and D. Again, the same idea is used. What idea? Angle in a semicircle is a right angle. So if you want to draw a circle through B, C, and D, B, C, and D, see, you want to draw a circle passing through B, C, and D. This is B, C. This is B, C, and this is D. So you want a circle passing through B, C, D like this. This is already 90. So angle in a semicircle is a right angle. This one is 90 degrees. If you have to draw a circle passing through B, C, and D, then BC should be the diameter. See here, there's that here, BDC, BDC. This BDC is there. You can see the BDC. You can see BDC here, BDC. And you can see the right angle. This is 90. If you have to draw a circle passing through BC and D, that means BC should be the diameter. BC should be the diameter. So if you know the diameter, it's so easy. You can find the center of the circle. If you know the diameter, you can easily find the center of the circle. How? By constructing the perpendicular bisector of the diameter. Construct the perpendicular bisector of the diameter. You will get the center. You know the diameter. So now it's so easy to find the radius, meaning the center of the circle. By constructing the divide the diameter into 2 equal halves by constructing its perpendicular bisector. And there you get the center. So with B and C as centers and convenient radius, you must use that 4-arc method and construct the perpendicular bisector of BC. So like this, you get a line like this. You'll get a line like this. So this is the center. This is the center. Perpendicular bisector of BC, children, you know how to construct the perpendicular bisector of BC with B and C as centers, convenient radius, arcs above and below BC. You'll get 4 arcs and join. So this is the center. This is the center of the circle. Now, how will you draw the circle? For the circle, you need 2 things. You need the center, you need the radius. If you want to draw a circle, you need 2 things. What is my center, or which is my center, and what should be the radius? If you have these 2 things, you can draw the circle. Center and radius. So center is O. Okay, then what should be the radius? OC or OB. Center is O, so that means you should put your compass at O. Put your compass at O. What should be the radius? OC or OB. So with O as center and OB or OC as radius, draw a circle. O as center, OB or OC as radius, draw a circle. Draw a circle. The circle will pass through B, C, and D. Because this is 90, angle in a semicircle is a right angle. It will pass through. The circle will pass through B, C, and D. You will get a circle. See here, this one, this circle. You will get a circle like this, passing through B, C, and D. Only then this is justified. Angle in a semicircle is the right angle. Okay, so we drew a circle passing through B, C, and D. Next, construct the tangents from A to the circle. Construct the tangents from A to the circle. Oh, we already have one tangent from A to the circle. We just need to construct the other one. Because from the external point A, we already have this tangent AB. That is AB, the side of the triangle AB is already acting as a tangent to the circle. Why? See, we need to construct the tangents from A to the circle, from A to the circle. A is the external point. So from the external point A, children, am I clear and audible?
Yes, ma'am.
Yes, ma'am.
Okay, thank you. So A is the external point. A is the external point. And from A, we know that we can draw two tangents to the circle. And we already have, see, AB is already a tangent. How do you know it's a tangent? Because OB is the radius. And see here, OB and AB are at right angles to OB and AB, they are at right angles to each other. Because that corner of the triangle is a right angle. This is OB, this is AB. See here, CB is the side of the triangle, CB. But OB is the radius. This one, OB is the radius of the circle. Look at the circle passing through B, C, and D. There's only one circle here. So OB is a radius. OB is the radius of the circle. And you can see that BA some line and OB makes 90 degrees with that line. So that means B is a tangent. This 90 degrees is not any meaning, not from any theorem. It's already given that this angle is 90 degrees. It's a right triangle. This is already 90. This is the radius. It makes 90 degrees with AB. That means AB is the tangent. And what's the length of this tangent AB? It is 6 centimeters. So what will be the length of the other tangent from A? That also will be 6 centimeters. Because we know that tangents from an external point to the circle are equal in length. We know that tangents from an tangents drawn from an external point to the circle are equal in length. So the length of the tangent AB is 6 centimeters. So from A, the other tangent also will measure 6 centimeters. So now you'll have to use your compass. Take your compass. Use a scale, or you can measure, put your compass here and measure AB, meaning expand your compass and take that radius 6 centimeters. Measure the length of the line segment AB. Put the center of the compass here, children. Put the center of your compass here and expand it till you reach the point B. So your compass tip is at A and your pencil tip is at B. Your compass tip is at A and your pencil tip is at B. Or you can do the other way also. You can put your compass tip at B and the pencil tip at A. So like you just expand your compass and you get 6 centimeters. When you do that, when you measure AB, you're getting 6 centimeters in your compass. Now that radius is 6 centimeters. Radius is 6 centimeters. Now with A center, and that radius 6 centimeters which you have on your compass, this is the circle. This is the circle. See, this is the circle. You drew a circle, no, passing through B, C, and D. That's a circle. So cut an arc on the circle. So where it will meet, you don't know. You just run your compass like that over the circle. Don't cut the arc, so you can cut it accordingly. So see, like you just move your compass. So somewhere here you'll cut it. And join. You can call this point B dash. Because AB is one tangent, you can call the other point B dash. Join AB dash. Join AB dash. AB is the length of one tangent from A, 6 centimeters. The other tangent from A is the external point to the circle. The two tangents from A will be equal in length. One tangent is 6 centimeters, so the other also will be 6 centimeters. So take 6 centimeters in your compass, put your compass tip at A and cut an arc on the circle at B dash. It will cut the circle only at one point like that. That will be B dash. Now join A, B dash. Join AB dash. So AB and AB dash are the required tangents to the circle from the external point A, and they measure 6 centimeters. That we did just because we know AB is 6. We did not find it in a different way. It's already given that AB is 6 centimeters. So this is how execute all the 4 instructions given. Let me do it quickly again. So first you draw the circle. Oh, sorry. First you draw the triangle that you know. First you draw the triangle. You know how to construct the triangle. Then we need to construct BD perpendicular from B. We need to draw BD perpendicular to AC. So what we do with B as a compass, B center, any convenient radius. Just it's like you're drawing a circle. So start like this, and you should get an arc which intersects the hypotenuse at 2 distinct points. Sometimes it will be very close also. Maybe you'll get it like this. Don't worry. You should find 2 distinct points, and you should see a small chord in the arc. In the arc, you must find a chord. That's all. You need to get this point and this point. That's all. You need to identify the 2 endpoints of the chord. That's all. So with B as center and convenient radius, draw an arc like this. So now you can see a chord contained by the arc. Now we'll have to bisect this chord. How? Using this and this, because this only is the chord. This is the chord. Using this one and this one as endpoints and any convenient radius. See, convenient radius meaning the arcs must meet. So using this one and this one as midpoints. I'm sorry, as endpoints. Compass. These are the endpoints. Convenient radius. One arc or the other arc. Now this point, like this. It will touch the chord. Stop there. When it touches the chord, stop there. Don't extend it. Stop there. That's the point D. D is the midpoint of the chord, and B is the center. BD is a line from the center to the midpoint of the chord. So it will be perpendicular to the chord. Therefore, BD is perpendicular to AC. Now next, to draw the circle passing through BC and D. We know that BC should be the diameter. BC should be the diameter. So on the diameter is the center of the circle. So we construct the perpendicular bisector of BC. And we locate the center of the circle that is to be drawn. So this is O. So with OB or OC as radius, we draw the circle which will pass through BC and D. Now A is from the external. Now for the circle, A is an external point. See, we have the triangle is 3 vertices A, B, and C. B and C are points on the circle. A is the point external to the circle. The 3 vertices of the triangle A, B, and C. B and C are points on the circle. They are the endpoints of the diameter. But A is the only vertex which is outside the circle. So A becomes the external point to the circle. B and C are the ends of the diameter. So B lies on the circle, C lies on the circle. Then of the 3 vertices A, B, and C, A is the external point. And now from A, we'll have to draw 2 tangents. AB is already a tangent. AB is equal to 6 centimeters. Compass, 6 centimeters radius. A center. Cut an arc on the circle. Call that point B dash. Cut an arc on the circle. So from here 6 centimeters, cut an arc. Only one point it will be. Otherwise, if you cut the arc, it will come here, it will come here. We don't need all this. Don't think it will come here. It will not come here. You cannot cut it. It will not come. Don't what if I can cut it here? You cannot cut it here. When you can cut it only here. Only at one point it will make a circle. Join. From A, join. Join AB dash. Call that point with A as center and radius 6 centimeters. We cut an arc on the circle. We cut an arc on the circle. We call that point B dash. Join AB dash. So AB and AB dash are the required tangents to the circle. Is that fine, children?
Yes, ma'am.
Okay. Draw a pair of tangents to a circle of radius 5 centimeters, which are inclined to each other at an angle of 60 degrees. So sometimes they'll say which are the draw a pair of tangents which are perpendicular to each other. We need to understand this information given. So I'll use a rough diagram first. So the construction will look like this. Circle. So for this one, for this construction, take up a rough diagram like this. And like fill in the details given in this figure. So we know the radius is 5 centimeters. 5 centimeters. Then the tangents are inclined to each other. See, this is one tangent. This is the other tangent. The tangents make an angle of 60 degrees between them. The tangents are inclined to each other. The tangents are inclined to each other at an angle of 60 degrees. The tangents are inclined to each other at an angle of 60 degrees. This one is 60 degrees. So what's the measure of this angle? Class, what will be the measure of this angle?
120 degrees.
120 degrees. 120 degrees. Who was that?
Shakti.
Shakti. So Shakti said, so Shakti is right. So if this is 60, this is going to be 120. What's the measure of this angle here? This angle?
90 degrees.
90 degree, ma'am. Radius per
What
unit.
about, yeah, what about this one?
90
degrees.
90. This rough figure is what you must first draw. This is the rough figure. So what did we do in the rough figure? What did we do? We drew a rough circle and then tangents like this, and then center, radius, radius. Tangents are inclined to each other at an angle of 60 degrees. They're inclined, the two tangents. So these are the two tangents. The angle between them is 60 degrees. Then this will be 120. If this is 50, this will be 130. Opposite angles are supplementary. Okay, so this is 120. This is not always 120 because this is 60, this is 120. If this is 50, this one will be 130. The opposite, these two angles are supplementary. Okay, now we know that these angles are 90 degrees. Radius of the circle 5. That's all. Just use this figure and construct. Now, if they say, draw tangents which are perpendicular to each other, that means the inclination is 90 degrees. If you have to draw tangents which are perpendicular to each other, draw the tangents that are perpendicular to each other. That means the inclination is 90 degrees. So it will be like this. You'll get a square kind of. I don't know if I can, 1 minute. One minute, I'm just trying to make a square first. Oh my God, it's a very difficult task. No, I can't do it like this. I got it. Yes. Like this. So like this, your construction will be like this, children. Yes. So if the tangents are perpendicular to each other, so this one, the angle between them should be 90 degrees. That means this one will be a rectangle or a square. It will be a square. This quadrilateral will be a square. This quadrilateral will be a square. Children, this is the external point P. This is the external point P. Am I audible, children?
Yes, ma'am.
Yes, ma'am.
Yeah. So class, lower your hands. Hariharan? Okay. All right, children. So if you have to draw tangents that are perpendicular to each other, that means this angle. Tangents that are perpendicular to each other from an external point. So that means this is 90 degrees. This one is 90. So then this also will be 90. This will be 90. This is already 90, radius tangent perpendicular. This is already 90, radius tangent perpendicular. So this one is a rectangle, but since the adjacent sides are equal, this will be a square. So we'll get a square here. So that's just an information. So this will be the rough. This will be the rough diagram. This will be the rough diagram if the tangents are inclined to each other at an angle of 90 degrees. So that inclination between the tangents must be marked here. The inclination between the tangents must be marked here. 90 degrees here. This is 90. 60 here. This one. This is the inclination. Now we should use this figure and construct one by one or step by step. So what does this figure say? According to this figure, radius is 5 children is given. In the information it's given that radius is 5. So you know you have to first draw the circle with radius 5 centimeters. Draw. First we have to draw a circle with radius 5 centimeters. Okay, done. Next, from where to start? You should start with OA or OB. You should start with OA. See, to construct any angle, you need a baseline. Without a baseline, you cannot come. You see, if you have to construct 60 degrees, simply like that with the protractor, you cannot construct 60. You cannot just draw this one as 60. You will first draw the baseline. And then with respect to the baseline, you will say that this is whatever angle, 30 degrees or whatever. So baseline. So here the baseline is one of the radii. Take any one of the two radii. That will be the baseline. So you can either take up OA or OB. You can either take up, you need a baseline. So either take OA or OB. So somewhere on the circumference, take a point and mark it A. It's not constructing something and finding A. Just take any point on the circle and call it A. And join O to A. So now you got a baseline. Now on this baseline, what should you do? You should construct 90 degrees here. See, that's what this rough figure is telling. Here 90 degrees. At A, you should construct, see the rough figure. It says at A make 90 degrees. At O make 120 degrees. So how will we see this? I'm using the rough figure. At O, how will I make 120 with O as center and a small radius? I'm going to first define an arc like this. 120 degrees, children. Then with the same radius. See, with O as center, compass any small radius, draw an arc like this. O center, a very small radius, draw an arc like this. Now don't change the radius. Put your compass here and cut an arc. with the same radius. Now put your compass here and cut an arc. So this is 120. If you join this, this will be 120. If you join this, because this is 60 and this is 120. So that is B. Now you can see this one is 120. 120 and you got B. So A you will just take by yourself, but B you cannot take by yourself. So like that you get the radius OA and OB. So first circle radius 5 centimeters. So obviously you know the center because you use the compass, so you know the center. So you call it O. Then I said you need a baseline for constructing angle. So you just mark a point like this and call it A. According to this rough, see, I'm taking the help of this rough figure. Otherwise, I don't know. If I don't draw the rough figure, I'll be blind. I won't know what to do. So now this rough figure says take a point A like this and join. So I join. Now I can proceed in two ways. Either I can construct 90 degrees here or I can make 120 here. I choose to do 120 because I want the other radius also. I want the other radius. So I choose to do anything can be done first. You can make 90 degrees or you can make 120 degrees. Anything can be made first. Because you have a baseline now. On one end, see OA is the radius. At A you have to make 90 degrees. At O you have to make 120 degrees. Anything can be done first. So I want to do 120 first. So what I do, I take my compass. Then what do? I put my compass tip at O. Then what? I take a small radius. Then what? I draw an arc like this. Because I should get 120 this side. The other radius here like this. Then what? Don't change the radius, children. So with O as center and a small radius, we draw an arc with the same radius, with this one as this point as center and the same radius, first arc like this. This is 60 degrees. Now with this one as center and the same radius, don't change the radius. Cut. This is 120. This is 120. Now from the center like this, we get. Through this point, you should draw and find the other radius OB. Now clearly this angle is 120 degrees. So clearly this is 120. Clearly this is 120. Now after this, what? Now we got the other radius. Now what have we done? We are done with this one. We got the radius OA, we got the radius OB. Now we already finished 120. Now we have to do these two 90s. 60 we will not do, that will automatically get. We will not construct 60, that will automatically get. We'll construct the, they have to be inclined at 60 degrees. No, that 60 we will not use at all. We'll use the other three angles. So we made 120. Now next is we have to make 90 here and 90 here. Anything can be done first. So how will you make 90 here? This is again compass, any radius, any small radius. So with this as A as center, arc like this. Then from here, same radius, we should not change. With this one as center, cut an arc. Then with this as center, cut an arc. Now this is 60, this is 120. If you bisect, how will you bisect again? Now you can change the radius. After cutting these three arcs, you can change the radius. See, like now you started from O. O as center, you made this the first arc. Now the same radius, this is the second arc from this point, from the center. And with this as center, this is the third arc. So these three arcs you must cut with the same radius. Now you can adjust the compass. Now these, from using these 2 points, using this point and this point, use sufficient radius. And draw from here, draw an arc. From here, cut the earlier arc. Now if I draw the arc, I cannot I'll draw the line. So see, you will get a line like this. So that is from here, this is 60, this is 120. If you bisect, you will get 90. Similarly, construct 90 degrees here. How? Compass, put your compass here. First arc with the same radius. This is center with the same radius. This is a second arc and this is a third arc. 60 and 120. And bisect 60 and 120. Bisect 60 and 120. With this one and this one. For these three, this is the first arc, this is the second arc, this is the third arc, same radius. Now you can change the radius. With 60 degrees and 120 degrees as center, and convenient radius, draw these two arcs like this, and this is 90. This is 90. Now we have made 120 here, 90 here, and 90 here. So by angle sum property in the quadrilateral, this will be 60 degrees. So the two tangents will be inclined to each other at an angle of 60 degrees. See, some of us will make 90 degrees like this. How? Like if you will produce this slightly, you will extend this one, and you will draw a semicircle like this, and from here you will draw an arc, from here an arc, and then using these two, will whatever you have learned, however your middle school teacher has taught you, please proceed in the same way. Construction, I think we learn 6th or 7th standard. Whatever you can do this one. What I've been saying is from here, radius arc. Now same radius. Take this as center. Same radius, one arc here. Now shift, keep changing the centers. Now this is first this one was a center, then this one was a center. Now this is a center. Same radius. So this is 60. If you draw like this, this is 60. If you join this is 120. Between 60 and 120 is 90. So like this is 90. So to get this one, from 60 you should draw one arc, from 120 you should draw another arc. That will be 90. On these arcs you must put your compass. So this is how we draw tangents inclined to each other at an angle of 60 degrees. Is it fine, children?
Yes, ma'am.
Okay. All right. So if the tangents are inclined to each other at an angle of 90 degrees, circle with that given radius, then you should take a baseline. You should take a baseline. So this is the baseline, radius is the baseline. Everywhere 90 degrees you should construct. Construct 90 degrees here. Construct 90 degrees here. Here also 90 degrees you must construct. Here 90 degrees. So automatically this will be 90. That is, OA is the baseline. At O, construct 90 degrees. At A, construct 90 degrees. This is 90, construct 90 here, construct 90 here, and 90 here. 3 angles you should construct. 4th angle will automatically be 90. Like in the earlier one, we constructed 3 angles. We constructed 3 angles. In a quadrilateral, there are 4 angles. We constructed 3 of them. So like we constructed 90, another 90, and then this 120. We constructed 3 angles. And automatically this 60. Now for 90 degrees, you should make 90 here, 90 here, and 90 here. Then this will automatically be 90. So here, construct a tangent to a circle of radius 4 centimeters. Construct a tangent to a circle of radius 4 centimeters. Now, how do we, supposing you have to construct a, supposing the question is construct a tangent. Now you have a circle and they say take a point P on the circle and construct a tangent at P. Supposing they said draw a circle, some radius, okay, draw the circle, some radius. And they say take a point P on the circle, okay, took a point P on the circle. And they say draw the tangent passing through P or at P. For that, what should you do? So circle center O, so point P here, join OP, and simply construct 90 degrees here. Construct 90 degrees here. Join OP. Join OP. That is if the point P lies on the circle. If the point P lies inside the circle, we can't draw tangents because there is no tangent that can be drawn to a circle through a point lying inside the circle. If the point lies on the circle, one tangent. If the point lies outside the circle, two tangents. So only these two. So you know how to draw a pair of tangents. From an external point, you can draw two tangents. What is the other one? If the point lies on this, there are three positions of a point with respect to a circle. There are three positions a point can take with respect to a circle. The point can lie inside the circle. The point can lie on the circle. The point can lie outside the circle. If the point lies inside the circle, we cannot draw tangents passing through the point that lies inside the circle. If the point lies on the circle, there is one and only one tangent that can be drawn passing through this point P on the circle. If P lies outside the circle, from there we can draw exactly two tangents to the circle. So from outside point, we know two tangents, how to draw. Now this is if P lies on the circle. This is if P lies on the circle. If P lies on the circle, then so you know the center O. Take the point P and join OP. That will be the radius. And here construct 90 degrees. How? The same arc method. From P, draw an arc. With P as center, draw this arc. Then same radius with this one as center, one arc. And with this as center, another arc. This cannot be, the arc cannot come here. The arc will come somewhere here like this. Then the other arc. Now bisect these two. So you will get 90 degrees here like this. And produce it. Produce it. Simply construct 90 here, children. That's all. And you can get the tangent. Now this point, simply they have given, concentric circle and all that. So nothing to do with the concentric circle. Construct a tangent to a circle of radius 4 centimeters from a point on the concentric circle of radius 6 centimeters. Okay. So what they want us to do is they want us to draw a circle with radius 4 centimeters. Okay. Drawn. With the same center, with OS center and radius 6 centimeters, they want us to draw the other circle. Okay, drawn. Now that external point, no, that external point lies outside the circle, right? It lies outside the circle. It simply lies on the concentric circle. That's all. So that point P, anyways, you will take outside only, and you should take that point, that external point on the concentric circle. That's all. You should take a point on the concentric circle. So that means with center, with OS center, we draw one circle. With the same center, we draw the other circle. Now take a point P on the concentric circle of radius 6 centimeters. And from this point, you'll have to draw two tangents to the circle. So the procedure is the same. Just imagine that circle was not there, that concentric circle was not there. What will you do? That point P is here. Now what will you do? Will you not join OP? Do the same thing here, join this. Will you not construct the perpendicular bisect of this one? Do the same thing here, construct the perpendicular bisect of this one. Then will you not mark this point as M? And with this one as radius, will you not draw the circle? Do the same thing. With this as center and this one as radius, draw the circle. That circle will pass through these 2 points. That is, that line segment from the center to the external point will become the diameter to the new circle. Now these are the points. See, this one is one point, this is the other point. Join. These are the two tangents from the external point P to the circle. What you do normally do, one circle, external point, what will you do? You will join. Then what? Perpendicular bisector. Then what? M. Then what? With this and this as radius. I'm sorry, with this as center and this one as radius. You'll draw a circle so that this becomes a diameter. You'll draw a circle so that this becomes a diameter. Then what you do? This is the external point, and you'll join this and the same thing. Exactly the same thing we are doing here. Just that we have another circle, that's all. We just have a concentric circle. And you're taking this point on the concentric circle. You're just taking the point P on the concentric circle. Then the usual construction, we join this, we construct the perpendicular bisector. Then this one is M. And we draw a circle so that OP becomes the radius, diameter. Diameter. Oh God, sorry. Now you can see that inner circle and the new circle, these are the points of intersection. Join. Join. Now you should find the length of the time. Measure the length, meaning measure it using, you can use a divider if you want to do it like the perfect mathematical way, then you need to use a divider and check. But where we'll not do all that, we'll just put our scale on the paper and measure it. To do that, put your scale on the paper on your construction and measure the length of the tangent. And also verify the measurement by actual construction. Oh, sorry, calculation. So for that, we just join this. We'll just join this one. And this is the right triangle, because see, for the new circle, two circles we already have, two circles. The third circle, no, look at the third circle. Look at the third circle. This is angle in a semicircle. It's a right angle. See, so there's a right triangle basically. There's a right. This one is a right triangle. When you this one you join like this. When you join this is for the sake of calculating. When you join like this one is angle in a semicircle, which is a right angle. This one. So you have a right triangle basically. How much is OP? How much is OP? 6 centimeters, because O is the center and P is the point on the concentric circle. Radius is 6 centimeters. OP is 6. OP is 6 because O is the center and P is the external point, which lies on the concentric circle. So OP is 6, radius. If I call this T, OT. How much is OT? OT is 3. Oh, sorry, 4 centimeters. Because that's the radius of the inner circle. OT is the radius of the inner circle, 4. OP is the radius of the outer circle. It's the diameter of the new circle, but it's the radius of the outer circle. See how to identify the radius, center and the end points, O and T. O is the center, T is a point on the inner circle. So OT radius. OP is the radius because O is the center and where is P? It's a point on the outer circle. So that means OP should be the radius of the outer circle. OT, O is the center. T is a point on the inner circle. So OT is the radius and the radius is 4 centimeters. O is the center. P is a point on the outer circle. That means OP is a radius. Because this is center, this is a point on the circle. OP is the radius and that is 6 centimeters. So we know that this is 4 centimeters and OP is 6 centimeters. And it's a right triangle. It's a right triangle. This is 4 centimeters, this is 6 centimeters. So you can find TP using Pythagoras theorem. You can find TP using Pythagoras theorem. OP is the hypotenuse. OP is the hypotenuse. So it will be 36 square. That is, 6 square. 36 minus 4 square, 16. What is it? 36 minus 16 is 20. Square root of 20. I have a calculator with me. I'm finding the square root of 20, which is 4.47. 4.47 means approximately you will get TP is equal to 4. Using your scale, you should get 4.4 or 4.5. Using your scale, you should get 4.4 or 4.5 because 4.47 is the square root of 20. And in 8th standard, we've learned how to find the square root of an imperfect square, 20. 4 4s are 16. 4 is the remainder. The next pair comes down. Double the quotient. Whatever you add here, you should add here. Put a decimal point. Okay, I think earlier also I told you I'll share the recording, meaning a link which explains the procedure to find the square root. I'll share that today. So like that, you continue with this procedure to find the square root of 20. 4.47 or 4.5 approximately. So when you measure TP with the help of your scale, you should get 4.5 or 4.4, whatever. So measure its length is using the scale. Verify is by using Pythagoras theorem. You should identify the right triangle. And this is 90 degrees because the angle in a semicircle is a right angle. That new circle. In the new circle, this one is the diameter and this is the angle in a semicircle, that's a right angle. So it's a right triangle. OTP is a right triangle. And OTP, the thing is, OT is the radius of the inner circle. OP is the radius of the outer circle. So you know their lengths. TP is only new line segment, which is the tangent. And you can find TP using Pythagoras theorem. It should be the same. You must get 4.5 when you measure using your scale. All right, children, that's all I could do in today's class. All right, children, so that's all I could do in today's class. We'll continue on Friday. In the meantime, if you have any specific questions for which you need to know the construction, if you share it on WhatsApp with me, I'll put up the question on the slide and do it for the class. Just in case you have any specific question, or not only from constructions, from any other chapter, if you have any specific question, if you text me on WhatsApp, I can prepare the PPT. I can put up the question and do it in the class. Friday we'll continue with constructions, maybe for some half an hour, and then we'll do something else. All right, children, I hope the class was useful. That's it for today's session, children. Thank you so much. You may leave the call.
Thank you, ma'am.
Thank you.
Thank you. Thank you.
Thank you, children.